There we go. Okay, so today we lecture over circles. Hopefully it doesn't take all class. I did cut some stuff out. So this whole page is just definition. A circle is a set of points in the XY plane that are a fixed distance r from a fixed point hk. The fixed distance r is called the radius, and the fixed point hk is called the center of the circle. Let xy represent the coordinates of any point on a circle with radius r and center hk. Then the distance between xy and hk must always equal the radius r. And we do this by the distance formula. So the square root of x minus h squared plus y minus k squared equals r. And if you happen to square both sides of this equation, so if you were to square both sides of this, you would end up getting the standard form of an equation of a circle, which is right here. So the standard form of an equation of a circle with radius r and center hk is given by x minus h squared plus y minus k squared equals r squared. If your center is at 0, 0, then you end up with the equation of x squared plus y squared equals r squared. And if your radius happens to be 1, then you end up with something called the unit circle. Hey, that's something we're going to be seeing a lot of this semester. Only when we get to chapter 7. Yeah, chapter 7. So this is the unit circle. Okay, but for now, we're just learning about regular old circles. So remember that first formula above. X minus h squared plus y minus k squared equals r squared. And let's try it out. So first question or first example, if the radius is 5 and the center is negative 3, 6, write the standard form of a circle. Okay, let me just zoom in a bit. There we go. So they're giving us other components. They say radius 5, center is negative 3, 6, write the standard form. So we know the standard form of a circle is given by x minus h squared plus y minus k squared equals r squared. And negative 3, 6, the center, we know that this is given as hk. So all we have to do, simple enough, is just plug in h, plug in k, plug in r, and that's as easy as it can be. This is just getting the standard form when you are given the pieces. So our answer here should be x, actually minus 3. So it's going to be x plus 3 squared plus y minus 6 squared equal to 5 squared, which gives me 25. And there you have it. This is the standard form of a circle, given the radius and given the center. All you have to do is plug in the components. All right. All good on that?
Yeah.
Yay. Like, yay, one yay. Perfect. All right. B, same thing. Find the radius of the circle if the center is located at 1, 2, and 1, 0 is a point on the circle. Find the standard form. So once again, I'll just write the standard form just so we have it. The more you write it, the more it burns into your brain. So they are giving us the center. So 1, 2 is our HK, which means I'll plug those in for H and K, which will give me X minus 1 squared plus Y minus 2 squared equal to, what they haven't given us is R squared. So how do we figure out the radius of this equation? And there's two
solve on the
possible
left side
ways.
and then square root it.
Good. So solve for the left side. So is there an X and Y value I can plug in order to solve the left side?
Yeah, it's the 1.10, right?
Good. So this is X, Y. So all we have to do to solve for r is plug in 1 for x and 0 for y. Good. So let's try that. So you'll get 0, not 0. Oop. Well, you would get 0, but 1 minus 1 squared plus 0 minus 2 squared equals r squared. And then we'll move up to here. Simplify. This will give you 0 squared, or just 0, because we know that'll give us 0. And then plus, and then you'll get negative 2 squared, which is 4, equal to r squared. 4 equals r squared. Therefore, r is what value?
16.
Well, we're not squaring it again. We're square rooting.
Could it be plus or minus 2, or is it just 2?
It can be plus or minus 2. That's good, because remember, whenever you square root something, you should get plus or minus. And that'll make sense for a circle, because think about it. If you have the center of the circle, your radius goes up, down, right, and left. Oh, what was that? All right. So this means our radius is positive or negative 2, and then this means we can complete the actual equation of this given circle. So we will have x minus 1 squared plus y minus 2 squared equal to 4. And there it is. All right. Any questions on that? I guess technically we didn't need to solve for r. All we needed was r squared, because that's what we were looking for right there. All right. Oh, and I said there was another way to solve it. Well, yes, just look at the points. Look at the difference between your points, the center and the circle. If your center is at 2 and a point on the circle, or if your center is at 1, 2 and a point on the circle is at 1, 0, what is the difference between those two y values?
2.
2. Therefore, your radius has to be 4. Hey, look at that. Saved us a bunch of time, huh? Okay, excellent. So,
You mean, wait, radius squared? I mean,
well, yeah, so, well, the radius is 2, but that means radius squared would be 4. Okay, everybody good with those? Basically, you're given the pieces, just put them together to create the equation of a circle. Nothing crazy. Okay. Next is graphing. So here we are given the standard form of the circle, and it wants us to find the center, radius, and any intercepts. So this means that based on the equation given above, what is my center going to be?
3, -2.
Remember that, think of transformations. If it's plus 3, then my x value is
negative
going to be
3,
what?
2.
Good. -3, +2. Because you have to think of transformations on this. If it's plus 3, this means you're going to move to the left 3. And if it's -2, this means we're going up 2. So our center is at -3, 2. Does that make sense?
Unfortunately, yes.
And what is my radius? If r squared is 16, then my radius has to be?
Plus
or minus
-4.
4.
Good, plus or minus 4. So we could just say 4, but I mean, like I said, don't knock points off if you put plus or minus 4. Because like I said, you'll plot the center and you'll go up 4, down 4, left 4, right 4. So that plus or minus takes care of that. Okay, on my math lab, it's probably just going to want 4 as the answer, I think. Okay, and now before we graph this, let's go ahead and find intercepts. This is a review process because we have to remember how to find x-intercepts And we have to remember how to find y-intercepts. So let's get started by finding x-intercepts.
That would be to make the y equal to 0, right?
Perfect. Good. So to find an x-intercept, you let y equal 0, meaning we plug 0 in for that y value up there, and we solve for x. So we'll get x plus 3 squared plus, and if we're plugging 0 in, then that's just going to be negative 2 squared equal to 16. And then square that, x plus 3 squared plus 4 equal to 16. Move that 4 over, and you'll get x plus 3 squared equal to 12. And then what do we do to both sides?
Square root.
Square root. And then can you break down the square root of 12 more?
Yes. 2 square root of 3, right?
So you get plus or minus 2 square root of 3. Because remember that this can break down into the square root of 4 and the square root of 3, which will lead us to 2 square root of 3. Okay. And then just move that 3 over and you have your x-intercepts. Ugly at that. Negative 3 plus or minus 2 square root 3. And if you really want to know their location, then definitely plug that into a calculator and get the decimal numbers. Okay, and then that's finding x-intercepts. How about the y-intercept?
Make x equal to 0.
That's it. Good. See, what a lovely algebra review. So if we let x equal 0, this means you'll get 3 squared plus, what is that? Y minus 2 squared equal to 16, right? Equal to 16. Yes. Then you'll get 9 plus y minus 2 squared equal to 16. Move the 9 over. Y minus 2 squared equals 7. And once again, square root both sides. And we'll get y minus 2 equals plus or minus 7. Square root of 7. And y equals 2 plus or minus square root 7. Now, those are just nasty, right?
Absolutely.
Gross.
Nothing a little calculator couldn't help you, but I think when you graph circles on my math lab, it's just going to ask you for the center and the radius, and that's all you have to do. But knowing how to find x and y intercepts is definitely important because, again, it's just algebra based. So all we have to do is, like I said, ooh, what fun colors could I use? There we go. Perfect. Let's plot our center, negative 3 and 2, which is right there. And then from this point, we are going to go up 4 units. So 1, 2, 3, 4. We're going to go to the right 4 units. 1, 2, 3, 4. To the left 4 units. And down 4 units. And all we have to do is connect the dots. Look at my circle. Looks just like the other one.
Beautiful.
Perfect. I wonder if I can do this. Hang on. Shapes. Ink to shape. Ooh, look at this. Oh, almost. Give me that shape. Where are you? No, it won't do it. All right, fine. You get the ugly circle then. All right, perfect. Any questions on that process?
Nope. No, sir.
Not bad, right? Okay. So we have been given the standard form of a circle. The next thing we are given is the general form of the circle. Basically, what this form is you took the standard form, you foiled everything out and moved everything to the left side. So this is the general form. It's everything foiled out and moved to the left side of the equation. So our job is, when we get to the problem, is we're going to take the general form and we're going to have to put it back into the standard form. And the only way to put it back into the standard form is to complete the square. So it's actually fun to say. You will complete the square to create the equation of a circle. Pa.
Mind blown.
That's
So,
fun.
That's fun. It's always fun, Ethan, okay? So for this one, write the standard form and general form of the equation of each circle of radius r and center hk. So this one, again, they're giving us the components. We're going to write the standard form and we're going to FOIL everything out to get the general form. So nothing crazy. And then I guess we'll graph it. So for this one, once again, I'll write the standard form, x minus h squared plus y minus k squared equal to r squared. They're giving us the center, they're giving us the radius. So let's plug them in. You'll get x minus 6 squared plus y plus, I was going to put 10. Y plus 8 squared equal to 100. Okay, so this is the standard form. All right. And then let's go ahead and create the general form. And to get to the general form, all we're going to do is FOIL everything out and move that 100 to the left side. So what does x minus 6 squared FOIL out to?
X squared minus 12 plus 36.
Good. Plus what else?
Y squared plus 16x plus 64.
16y, right?
No, sorry, yeah, sorry.
You're good. Equal to 100.
Then subtract.
There you go. I guess before we subtract, though, we could add these two up, right?
Wait, is that just going to be 0 then?
So when we move the 100, then yeah, it'll just become 0. Because you'll get x squared minus 12x plus y squared plus 16y plus 100 equal to 100. And if you move that 100 over, then yes, these will cancel and leave us with the general form of x squared minus 12x plus y squared plus 16y equal to 0. General form, standard form. San Francisco. Good. Okay. And now it's said to graph it. So do we even have room? Probably not. But let's see. 6, 8. Radius is 10. Oh, goodness. Is that going to go off the paper? Not if we say that these go by 2s, though, right? So let's do it again. Make that smaller. All right, 6, 1, 2, 3, 4, 5, 6, and -8, which is there. And from that point, our radius is 10. So you'll go left 10, up 10, down 10. Oh, yeah. So it's going to go off the paper, but all good. 6,
Unless you do it by 2.
8. Well, down here, you're still going to go off, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And yeah, unless you did go by 2s. Oh, well. So we're going to have a really huge circle. Or if you go by 2s, you might not. Yeah, there we go. Look at that. Good enough. Okay. Any questions on going from standard form to general form?
So are we gonna have to go from general form to standard form?
Yes,
using
that's
include squared, except
exactly. Good. And I think that's next. So I guess everybody's good. All right. Here it is. Okay. So graph the equation x squared plus y squared plus 4x minus 6y plus 12 equal to 0. Find the center, radius, and intercepts. So in order to graph this, they're giving us general form, and we need to put it into standard form. So the first thing we're going to do is put the like variables together. Where did I have the room? Over here, I think. Good. So I'm going to rewrite this as x squared plus 4x, and then plus y squared minus 6y. And I'm going to move that 12 over to the right. So all I've done is put the like terms together. X squared with 4x, y squared with negative 6y, move the constant of 12 over to the right. And now in order to go from general form to standard form, we have to complete the square on the x's and the y's. So here we must complete the square, and here we have to complete the square. So I'll just say CTS. And if you don't remember completing the square, all good. Here's a little refresher. For x squared plus 4x, we're going to take half of what number?
the 4x.
Just the 4, right?
The 4, yeah,
Just the coefficient, right? You're going to take
Then
half of it and do what with it?
square it.
Square it.
Square it. So you'll get 2 squared, which gives me 4. And then let's go ahead and do it for the y's. What number am I going to take half of?
6.
6 or negative 6, don't matter, right? Because it's going to come out positive either way. Negative 6 squared gives me negative 3 squared, and we get 9. Perfect. Now, what do I do with those numbers?
You're gonna add to both sides.
Good. I'll get x squared plus 4x plus 4. Right, come on. Plus y squared minus 6y plus 9 equal to, what do I have? Negative 12 plus what?
So you're gonna add the 4 and add the 9?
Very good. 4.
Oh, wow.
You see? Excitement in that voice. So you're going to add the 4 and the 9 to the right side as well. Everybody good with that?
Is there?
Okay. And now since we have completed the square, we are ready to put this in standard form. So remember that once you complete the square on an expression, it becomes factorable after that. So this means that all of this and
X
all
plus 2.
that, good, we can factor it. Let me write that.
It's always that factorable to, I don't want to say, is it perfect square you call it?
Yeah.
Or?
3. Yes.
Yeah, for sure. It becomes a perfect square. So I'm pretty sure you said it already, but let me catch up. X squared plus 4x plus 4 will factor to?
X plus 2 squared.
Good.
Or like the entire factor squared.
Yep.
And then y minus 3, and then that
Squared.
entire factor squared.
And then the right side just becomes what number?
1.
Good. And there you go.
Standard form.
You got standard form, which means we can now graph this because we know the center. What is the center?
-2, 3.
And the radius is?
1.
Yeah.
Oh, wait. Yeah,
There
1.
you go.
Yeah, 1 squared is still 1.
So if we plot that, -2 and 3, my radius is 1. So I go up 1, right 1, left 1, down 1. Look at that. And I probably still can't make a circle out of that.
You can always try.
There you go. Good times. Oh, and it said intercepts. Oh, good thing for us. Are there any X and Y intercepts?
No.
Why not?
It's not touching any lines.
There you go. So there's no intercepts because we don't touch the y-axis and we don't touch the x-axis, right? Excellent.
If you try to figure that out algebraically, would just like did
Let's-
before set
Yeah,
x equal to 0 or y equal to 0,
for sure.
but then it wouldn't. Well, it would equal like irrational number or something.
Not just
Or,
irrational, but what?
Imaginary.
Imaginary. Yeah, let's check it out. Why not? We have the time. So if we try to solve for an x-intercept, you let y equal 0, and then x plus 2 squared plus -3 squared. We'd get x plus 2 squared plus 9 equal to 1. You move that 9 over, and we get x plus 2 squared equals -8.
Square root of -8, right?
And then you square root. And just like you said, when you square root a negative number, you get what?
Imaginary.
Oh, I.
You get I, right? You get imaginary, which means that you're going to get the same result for the y-intercepts because by our graph, we don't cross any of the axes. So this means that there are no intercepts. Yay. Why can't we draw good circles? I don't know. Just wasn't destined. I wonder if I could do it on here. Let me see. Let's see what this thing does. Math. Write your equation in ink. I did. And then select it. And tap the math button. Hey. Oh, it thinks that's an I. Fix. It's a 1. Done. Oh. Nope. Oh, well. It would usually graph it, but I think my 1's all messed up. Oh, good. Okay. Cool. So, any questions on going from general form to standard form? If you didn't remember the complete the square process, well, there it is, right? Take half of the middle term's coefficient, square it, and add it to both sides. But feeling good?
Yes, sir.
All right. Okay, next page. Some more fun stuff with circles, right? Okay. So find the standard form of each circle. And for A, it says that our center is at 3, -1, and we are tangent to the y-axis. So I guess the big thing here is, what does it mean to be tangent? One, 2, 3, -1. There's our center. All right. And again, it's okay if you don't know what tangent means. Maybe it's the first time you see it. Maybe you don't remember it. But to be tangent with something means you share 1 point with. So a function can share 1 point with another function, or a line can share a point with another line. This is what it means to be tangent. So if we are tangent with the y-axis, which maybe I'll draw another line here. Let's see. I'll just do that in purple or something. So here's my y-axis, and it says we are tangent. Our circle is tangent with the y-axis. This means that my circle comes down, shares 1 point with the y-axis, and takes
wait,
off.
1 sec. So tangent only means 1 point. That's it. No more points. Okay.
That's it. So if we share 1 point with the y-axis from my center, what point do you think we share with the y-axis?
The radius, -1, 0.
Well, 0, -1.
0, -1. Yeah, sir.
There you go. Which means my radius happens to be how many units?
3.
3. Good. There it is. Which means if my radius is 3, that means you'll go 3 to the right, you'll go up 3 units, and you'll go down 3 units. And there's our circle. And to show it being tangent, it just comes down, shares that point, takes off, and there you go. That's it. So tangent means you share 1 point with a function, and that's it. So that's what being tangent is. And that means we can complete the standard form, because now we know that the radius is 3, and therefore the equation of this circle is x minus 3 squared plus y plus 1 squared equal to 9. Any questions on that before moving on? All right, my silent class.
All good.
In the hood.
Perfect. Okay. So next one again, just find the standard form of the equation of a circle given the endpoints on a diameter. Here you have 7, 6 and -5, 4. So in order to find the center, which we know is between the endpoints, we have to use something called the midpoint formula, which is given there. So let's go ahead and plot these points first. 7, 6. Let's see. 7, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6. There's one endpoint, and then -5, 4. 1, 2, 3. 1, 2, 3, 4, 5, and 1, 2, 3, 4. There we go. Okay, so there's our endpoints that they give us. And now let's go ahead and use the midpoint formula to find the center. And everything's given there. x1 plus x2 over 2, y1 plus y2 over 2. So let's just zoom in a bit. And we're going to say that our center is going to be at and x1. So 7 and 6 will make that x1, y1. Negative 5 and 4 will make that x2, y2. So I'll have 7 plus negative 5 over 2. And then y1, 6 plus y2 over 2. So this means that my center is going to be at, what's that?
1,
2,
5.
5.
1, 5. Perfect. So let's go ahead and plot the center then. 1, 5. 1, 1, 2, 3, 4, 5. Okay. So we have the center now, but what we need to figure out next is what piece are we missing?
The radius.
The radius. Good. So we have the standard form there, x minus 1 squared plus y minus 5 squared equal to r squared. And in order to find the radius, what could we do?
Rise over run. So go like down 1 point.
So you think like trying to find a slope will get us there?
Yeah. And then like, divide it maybe, and then like square it.
Good, that's an option. Or do we have an x and y value we can plug in to help us solve for r?
Yeah.
Yeah, just one of the points, right?
Yeah, you can use either one you want. Why not plug in 7, 6 or negative 5, 4 into x and y, and that'll help us solve for r. So
okay, gotcha.
yeah. So let's go ahead and just use 7, 6. That seems like the easier option, right? So
yeah.
We'll have 7 minus 1 squared plus 6 minus 5 squared equal to r squared. And then this will give me 6 squared plus 1 squared equal to r squared. And then you'll get
37.
36 plus
Gross
1.
number.
You'll get 37 equals r squared.
And then you square both sides. And
then if you square both sides, our radius is just the square root
minus 37.
plus square root of
37.
37. But since we're graphing this, let's go ahead and figure out what the square root of 37 is.
Lord.
Yes, it's Lord.
Cool.
There you go. We'll go up Lord units, down Lord units.
Put on the test. Do we get credit?
Right, Lord unit.
6.08. So why not just go to we'll just do it by sixes, right? Go down 6, up 6, so you can complete your circle. And I guess we need to complete the standard form as well. So let's go ahead and do that first. The final form would be x minus 1 squared plus y minus 5 squared equal to 37. There's our standard form. Now finish your circle. So for the radius, I just go down 6, 1, 2, 3, 4, 5, 6, and then some. 1, 2, 3, 4, 5, 6, and then some. And 1, 2, 3, 4, 5, 6. So like that, or maybe a little out. Let's see. And 1, 2, 3, 4, 5, 1, 2, 3, 6. There we go. Hey, look at that. And then circle time. As best as you can do it.
Quick
Good
question.
onion.
Yes, go ahead.
Could you use either point, so like the first one or the second one?
Like to figure out the radius?
Yes, or does it matter which point you
It
use?
doesn't matter. You can use 7, 6, or you can use negative 5, 4. Either way, you're going to get 37.
Got it.
Good question. Good.
We're gonna use this when we get to Cal 2 for the Fourier series, aren't we?
What, circles?
The standard form.
Standard form, I don't know. Depends. Depends on what you're going over, but you're reaching out there. Because I know you'll do like integrals of conics and stuff. So yeah. So I'm just gonna say whatever you're learning in pre-cal, you're not gonna really see until Cal 2. So don't forget it. For now, conics, when we go circles, ellipses, hyperbolas, and parabolas, it's just one big algebra review. That's all this is. With a little
Good
bit
thing
of
all I needed
graphing.
to was pre-cal and cal 1.
There you go. There will be a little bit of trig in Cal 1, but
Boo.
that's it. That's it. The trig comes back really hard in Cal 2.
That's what we're here for.
There you go. Okay. So there is circles, and we made it to the last page, I believe. So are there any questions on the previous problems before I keep going?
No, sir.
That's one no. Anybody else?
No, sir.
I don't sound as happy as him, but negative.
No, sir.
All right, good. Okay. See, circles are pretty straightforward until you come to this problem.
Yes.
Hey, look at that. Tangent line again. See, we see it again. And tangent lines will haunt you in Calculus 1. So why not see them now? So the Greek method for finding the equation of the tangent line to a circle uses the fact that at any point on the circle, the line containing the center and the tangent line are perpendicular. Use this method to find an equation of the tangent line to the circle x squared plus y squared equals 9 at the point 1, 2 square root of 2. Ooh la la. All right. So first things first, let's go ahead and graph our circle. It's x squared plus y squared equals 9. Go ahead.
Is it saying 1 and then 2 square root of 2 is the tangent point?
No,
Okay.
1, 2
Or
squared root of
that's
2.
the center.
That is a point on the circle. 1 square root,
Okay.
1, 2 square root of 2. So for
That's just
now,
a random point on the circle.
exactly. So, and at this point, we are going to find the tangent line.
Okay, yeah.
So for now, what they're giving us is our circle is given by the equation x squared plus y squared equals 9, which means if you're given this equation, our center is where?
0, 0.
Good. Our center is at 0, 0. And what is my radius?
Plus or minus 3.
Plus or minus
Yeah.
3.
Yeah.
So right 3, down 3, left 3, up 3. And let's go ahead and draw our circle. Okay. And now let's go ahead and put this point on the circle. So it doesn't have to be perfect, but where do you think 1, 2 square root of 2 is?
Between
could
1
say-
and 2.
Where okay, yeah, go over 1 and then just go all the way up to.
So probably
where the
right here,
circle-
right?
Yeah.
Yeah, why not? That's our point.
Must
Here's the
be.
point. 1.
Well, then it's perpendicular, so
2 square root of 2.
I'm getting this.
Well, okay. So no, we haven't even got to the tangent line yet, right? So all I wanted to do was draw a diagram. And now let's go ahead and look at this problem again. We want to find an equation of the tangent line, meaning that to be tangent means you share a point with the function, right? So what this is saying is that by this Greek method, it says that the line that contains the center and the tangent line are perpendicular. So what that means is that there's a line that goes through the center and the point given on the circle.
And that would be the secant line, right?
That would be a secant, correct. Good. That would be a secant line. And what it's saying is that whatever line that contains the center will be perpendicular to the tangent line, meaning there's going to be a line that cuts through like this. And it shares that one point with a circle and takes off. And not only does it share one point and that it's tangent, it is also, like the problem says, perpendicular to the line that it intersects with.
And
So,
its slope is a derivative?
No derivatives, nothing crazy yet, right? So we have to go back and think about what being perpendicular means, right? And when we say perpendicular, I'm talking in terms of slopes. So what does it mean to be parallel? To be parallel, two lines have the same.
You have the same slope, but different y-intercepts.
Yes, good. So mainly just being parallel means two lines have the same slope. Anybody knows what it means to be perpendicular lines?
Isn't it like negative function or no? No. You know what? I'm not too sure.
They're gonna have one point of intersection, but
so
isn't it like negative slope and then it's flipped around or something like that? It's like 1/3.
You're almost there.
Okay,
almost got it.
Say the slope is 3x, it would be negative 1/3 x, right?
You got it. You got it.
Yeah.
So to be perpendicular, if two lines are perpendicular, this means that they are negative reciprocals of each other. So this means that if slope 1 is, I'll just say, if slope 1, I'll just make a number. If slope 1 is 5, this means that if you're perpendicular, slope 2 is the negative reciprocal of 5. So what would the negative reciprocal of 5? Good. The negative reciprocal of 5 would be 1/5. So this is what it means to be perpendicular. So this means that we have our work cut out for us, because what we need to do first is find the slope of the line that contains the center. And if we find the slope of that line, this means we find the slope of this line. Make sense? I'll just put this because this isn't part of the problem. This is just a note. Okay, so now, like I said, we're just thinking way back when we learned about slopes. So we just brought back the perpendicular to remind you, or maybe you've never seen it before, or maybe it's been years. Now, step 2 is, how do you find the slope between 2 points?
Rise or run?
I'm good, but I'm looking for more of a formula. What is the formula to find
isn't
slope?
Isn't it like x1 minus x2 and then y1 minus y2 the x1? No. Okay. No. I got it.
Y2 minus y1 over x2 minus x1.
There you go.
Oh, okay. No, I was thinking of.
Sorry, I cut you off, bro.
Average rate of change.
Look at those brains firing off. All right. So remember, to find the slope between 2 points, it's always y2 minus y1 over x2 minus x1, which means we need 2 points, x1, y1, and x2, y2. So let's just focus on this line first. What are the 2 points that we know?
1, 2, or
yep. Yeah, 1 and 2 square root of 2. And what's the other point that we know?
1 negative 2 square root of 2.
Well,
or the
0, 0. 0, 0. Why not? Now, what we're going to do is, between these 2 points, we're going to find the slope of this given line. So let's go ahead and do that. I'm going to say find slope between 0, 0 and 1, 2 square root of 2. Which means we're going to get m equals, and we're going to do the y2 minus y1. So I'm going to label these then. This is going to be x1, y1, x2, y2. And we're going to have 2 square root of 2 minus 0 over 1 minus 0. Hey, that's easy. So what is the slope of this line?
2 square root of 2.
Perfect. Okay. But now we don't care about this line anymore.
Negative reciprocal.
Good. Now we care about this line. And our job is to find the equation of this line. This line is called the tangent line.
Okay, but we also have the point of it still, and now we have the slope. So now we can create we go to point intercept form, right?
Very
point
good.
Slope form. Or...
You got it. So this means that now we are going to find the equation of the tangent line. And I'm going to let you know that there are only 2 ingredients you need to find an equation of any line. And those 2 ingredients are a slope and a point. Well, we have the point. The point on the tangent line is that 1, 2 square root of 2. The next thing we have is the slope. But remember, it's not the slope 2 square root of 2. It has to be what?
The negative
reciprocal. But is that
negative reciprocal?
Since it's negative reciprocal, is that going to put a irrational value in the denominator?
Yes, which means that the
Gross.
slope of the tangent line, here, I'll put m tangent. And what is the negative reciprocal of 2 square root of 2?
Well, that would be negative 1 over 2 square root of 2.
And now, can I leave it like that?
No.
No.
What do I have to do? What's the process called?
It's called rationalizing. So you're going to multiply by just
radical 2.
Just radical 2 over radical 2. And this is going to give me the negative square root of 2 over what?
Four.
8.
4.
Over, 4.
Because
yeah.
square root of 2 times square root of 2 becomes what?
2 times 2.
Well, just 2. Because it becomes the square root of 4, which then becomes 2. Okay, so now we have the slope of the tangent line. And I said the other ingredient we need is a point. Well, the point that the tangent line crosses through is the one they gave us in the very beginning.
1, 2 square root of 2.
2 square root of 2. Now we have the 2 ingredients we need. 1, 2 square root of 2, and the point 1, 2 square root of 2, and the slope of the tangent line. So now let me introduce you to another formula called the point slope formula. And what's great about this formula is it tells you what you need. It tells you, hey, you need a point and a slope, which we have both. So this is called point slope. Oops. And it's given as y minus y1 equal to m times x minus x1. And all we have to do is plug in the slope of m, which we have above, and plug in the y1 x value, which we have as well. and just solve for y. So this will be, I'll label it again, x1, y1, and we're going to get y minus y1, which is 2 square root of 2, equal to m, my slope, negative square root of 2 over 4, times x minus x1, which happens to be 1. I have plugged in all my components, and now all I have to do is solve for y. So we're going to distribute this nasty thing. And we're going to get y minus 2 square root of 2 equal to negative square root of 2 over 4x plus square root of 2 over 4. And then you're going to add this 2 square root of 2 over to the right side. And that should finish it. And I'm thinking it'll take this as your answer. This is the tangent line. But if it doesn't take it as your answer, then you're going to have to combine
those last two.
You're going to have to combine those two. So
How do we do that?
well, it's as simple as getting a common denominator.
Yes. Okay. So you multiply 4 to the 2 square root of 2, or
Yeah. So you'll do 2 square root of 2. You'll put it over 1, and just like you said, you'll multiply it by 4 over 4. And this will give you
okay. Yeah. That's not,
square root of 2 over 4 plus 8 square root of 2 over 4. And if you combine those two, what are you going to get?
8 square root. Yeah. 8 square root of 4.
Supposed to be technically
Or
9 square root
9 square root of 4.
There you go.
9 square root of 2 over 4. Sorry.
9 square root of 2 over 4. So if it doesn't take this, then you're going to want to type that in. So I'll just make a tiny little note. I'll say my math lab, if that's a possibility.
evil.
But guys, that is the tangent line for that circle. It's insane, right?
That was fun.
So on the last problem, as a rule of thumb, are we always going to find the slope and everything of the secant line first and then do the tangent line?
No. Well, if you're given a circle, I guess you would have to, but you're not going to do that for most of the time. So sometimes you'll be given a slope already and you'll be given a point, so it's a lot easier to do it. But for this one, you're going to have to go through this whole process. All right. Well, that was good.
Wait. Okay, wait. So all it says is that find the tangent line that touches it. It doesn't want us to find the other circle. Or wasn't there another circle?
No.
No, it's just the tangent line. Okay,
yeah,
okay.
It said find an equation of the tangent line to this circle at the given point. That's it. So whatever I boxed in purple down there, that is our answer.
Yes, sir.
Sweet. And then let's see, let's explore a little more. Do I have Desmos open? I think so. So I'm going to put this circle in. Let's see. X squared plus y squared equal to 9. There's that. And then I'm going to type in the tangent line we just created. Y equals, and it was negative square root of 2 over 4 x, and then plus, I guess I'll keep it simple by saying 9 square root of 2 over 4, right?
Yes, sir.
There we go. And now look at this. If I click on that, it should show the point, or maybe it doesn't, where they intersect. Show me. Dun, 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 dun. Or maybe I'll just type it in. Let's see. 1, 2, square root of 2. There we go. And there it is. That is the exact point they share. That is the only point they share. So you see this blue line comes down, touches the circle there, and then takes off.
So all that other area, that blue part, it's not actually touching. It's just getting really
No,
close.
I think if I zoom in enough,
that one
you can
point,
see
okay.
it's still, you see that? It's still not touching.
Need a microscope.
Yeah. Yeah, so if I kept zooming and zooming and zooming until I break this laptop, you'll see that that's the only point they share, but I don't think I'm gonna get there. Oh yeah, it's not zooming anymore. But there you go. So just checking our work by using that, which pretty neat. I guess that's good enough. So it comes in, shares a point, and takes off. Okay, well, other than that, that finishes our circle lesson. Circles are pretty straightforward until you get to that last problem. But what's great about this last problem is that it brings back a bunch of basic algebraic properties, such as what does it mean to be perpendicular? What does it mean about their slopes? How do you find the slope between 2 points? So we're bringing all this back that is somewhere stuck in the back of your mind. So you are welcome. Other than that, we have a lot of time left. So if you have questions over these notes, I definitely can go over whatever you need to. Definitely get started. Use this time to get started on your circles homework on my math lab, and I can answer any other questions that you may have issues with. So let me know.
And so this can be due a week from today.
Yes, so now you can work on circles, and it's going to be due next Thursday. So for now, I can answer questions over the circles notes, circles homework. I can answer questions over the review notes or the review homework. And if you are good, then I will see you on Tuesday. And everybody's going to be like, bye.